Good evening, everyone. This is Professor Lewis, and today we will be focusing on Module 10, Inheritances. Okay, so this demonstration introduces inheritance in Python. So let's take a quick look at the README file. All right, so again, this demonstration introduces inheritance in Python. So what is actually inheritances? Or inheritance. Inheritance allows a new class to extend an existing class. The new class inherits the members of the class that it extends. All right. And extends is just another term for inheriting. All right. This type of relationship is known as an is-a relationship, okay, which involves a superclass and a subclass. The superclass is the general class, and the subclass is what we call the specialized class. So what we're going to build today, if you can just briefly take a look at the UML diagram. All right, the arrow is pointing upwards towards our student class from our freshman and sophomore class. Okay, and that tells developers that these two class subclasses are inheriting from the superclass student. All right, so student is also what we call, again, our base class, all right, our superclass, and it contains all of the common attributes that each of these subclasses are able to use, such as the name, the student ID, and the major. Okay. It also contains its initializer, the constructor that will build the student object. Okay. And in addition to the attributes, it contains its getters and setters that allow us to gain access to and modify the values inside of our private attributes there. All right, I've also added a general method called display underscore student underscore level, all right, which each subclass, freshman and sophomore, will inherit as well. And they will specialize or customize that method specific to their class. Okay? And then finally, there's the toString method or the string method that, of course, displays our object's current state in a string type of format. Okay, so both of our subclasses, freshman and sophomore, will inherit from student. All right, our freshman subclass, all right, contains just one new attribute, all right, first year seminar. And this particular variable will simply set that particular course for the freshman student to take, the first year seminar. All right, so if you notice, it does not contain the name, the student ID, or the major. Why? Because we are inheriting those values from our superclass student. Okay, it will contain, all right, its own initializer or constructor, because we also want to build an object, a freshman object. All right, but if you notice here, we're also, well, you can't really see it here, but you'll see it shortly in the code, where we're going to invoke the superclasses constructor in order to set those values for the freshman, the name, the student ID, and the major. All right, and then in the constructor for freshmen, all right, we're adding the name, the student ID, the major, and its specific attribute, first year semester, seminar. Okay. And the only getter and setter that we'll need, right, are for this specific attribute, first year seminar. Okay. And why do we not need it for the other three, name, SID, and major? It's because we're able to utilize its getters and setters inside of our superclass that we inherit. Okay. So if you notice, we're going to inherit in what we call override, right? Override simply means that this subclass has inherited this display student level method, right? And we'll simply customize it or provide the specific implementation, right, for its class, right? And it will say something like, this is the freshman class inside of the, this is the freshman inside of the freshman class, right? We'll see that shortly. And then the freshman class itself also has its own toString method. Okay, so we're overriding that display student level, method from our superclass. So if we take a quick look at the sophomore class, it too defines its customized or specific attribute, credits completed, right? And this particular variable will store, right? Students have to have completed at least 45 credits in order to be considered a sophomore. All right, so we're going to set this particular attribute using its setter method. You notice here, all right, and then we'll retrieve it using its getter method. The same holds true. It has its own constructor, right, and it's adding the parameters for name, sit, and major, right, so that it too can, when its object is created, right, it will use the getters and setters. It will invoke the superclasses constructor to set those values. All right, but we're also setting the value for the completed credits completed as well, and we're initializing that to 0. It too will override the display student level method, right, and provide its own specialized implementation, right? But in addition to that, I've created this private method eligible for upper division, right? And the threshold here was set to 45. I've actually kind of modified this just a little, right, in the code. All right, so this is a private method that this sophomore class can only use, all right? That's what it's intended to do. Okay. So you can also, when you're implementing inheritance, you can also have specific specialized methods inside of your subclasses that are specific to that subclass. In addition to inheriting methods that these subclasses can override and provide their own implementation. Okay, so that's what this sophomore subclass is doing here. And we'll take a look at that shortly. All right, and then finally it has the string method again that will display the current state of that object that's currently in play. Okay, so this demonstration, right, as I said, creates we're going to create this university roster. We'll start with the student class that encapsulates the data using the getters and setters, as I stated. Then we'll extend the subclasses freshman and sophomore to see how inheritance works in action. And then each class, again, will customize that behavior by overriding that display student level method, okay, and enhancing the toString, this string method. All right, so therefore, when we loop over this single list of student references, right? So we're going to create a list of different students, freshmen and sophomore, right? We'll be able to print out each individual object, right? Based on its implementation inside of that object, right? Based on the implementation that we have coded for this display student level method. Okay, and this is known as polymorphism. Excuse me. So there's another class here, and I should have added it here, but it's the main class. And the main class will primarily be the driver, all right? But it will be a class inside of our module, all right? So we're going to create that one particular class, and we create one object of each type. So we'll create a student object, we'll create a freshman object, and we'll create a sophomore object, right? And we'll set their states using the setter method, and then we'll display their state by using their getter methods. Okay. Then we'll also take a look at how we can use the string method and the display student level method, and to see how that works across all of our classes. Okay. We'll also take a look at the isinstance method to confirm that a freshman and a sophomore are recognized as students. All right, therefore reinforcing that is a relationship. Okay, so by the end of this particular demonstration, you should be fairly comfortable with defining classes, calling the superclasses initializer using the super method, how to override methods nice and cleanly, how to validate input inside of the setter before that value instance is actually set, and then demonstrate how some of the polymorphic behavior works within inside of a loop. Okay. All right, so let's get started. All right, so the first class that I will create is our superclass. And I said that that class will be the student class. All right, so the next thing I'll do is to define the initializer. Okay. And let's add some parameters here. So I'm going to go ahead and set each of these parameters and initialize them to empty strings. And the reason I'm doing that is so that when we go to create the object, right, we can create it by using an empty set or an empty parameter list. Okay, and I'll explain that as we get to when we get to our main class. Because if not, we would be able to use our setter, but it makes more sense to implement it this way. All right, so we'll do our SID student ID, and we'll initialize it as a string here. And then our major. Initialize that as well. String. And for the major, I'll type in a value undeclared. And so this is our initializer for the student class. All right, so let's go ahead and let's finish this out. So we'll do self underscore name. So the intent with the underscore is to show that that particular attribute is private. So we'll do this for each. I'll just do a quick copy and paste here. Let's rename it. Do it the opposite way. And what do we have? Just one more. Okay. We'll set our major. So the key here is, this is the initializer. Again, this is the constructor. It's what we call them in Java, constructors, which is synonymous to initializer in Python. So what this does, this particular method, special method will, excuse me, will actually create the object for us. All right, so whenever I do something like, let's say student, let's call it my student equals student, right? Here, I'm actually invoking this method here. All right, and what we're going to do, we're going to use this my student object and to set the values for these attributes here. Okay. So this is how this actually works. It's actually quite interesting. Okay. Really cool. All right, so next let's create our getters and setters. And I'll create the very first getter and setter. Let's see. Yeah, and then I'll copy and paste the rest, right? Because they're pretty much the same when you're working with getters and setters. There's nothing really special about them, except they allow us to gain access to our private attribute, which is special. Okay, so we want to use the word get, right? Underscore to indicate that this attribute is private. Right, and we use our self so that the compiler can reference the actual object that we're using. And then get returns a value, right? So we want to return the actual name, right? Whatever value we have set inside of this variable here, or this attribute here. All right, so that's a getter. All right, so we started with get, It's private underscore name. All right, the same holds true here. This is what we're going to return. All right, so let's do a setter. All right, so we start it with the word set. Makes sense? But this time we need to pass in an additional parameter because we're setting this attribute name to a different value. All right, so I have called it stu for student name. So what does that mean? That means in order for this set name method setter to work, all right, I need to pass a value in there, some type of argument into this method. All right, so that I can set it. So I can set it to a specific value. And if you notice, it looks just like, I can actually do a copy and paste here. All right, and it looks exactly like our constructor, the same way that we build our object. All right, it looks the exact same way. Right, with the exception that it is using the correction. My mistake. It does not look the same way. Switch that because our arguments are different. If the arguments were the same, they would look the same way. The parameters are different. Okay. But the syntax itself is the exact same as our constructor, our initializer. Okay, so in order to set, all right, so basically this setter is saying, okay, so you want to change the value to name inside of this student object. All right, so we've created the object and we want to change the name, or we want to add a name to this attribute. All right, so we will use this set underscore name method to do that. So in order to do that, I need to pass a name in there. So it will take that name that I have passed in, all right, it will convert it to a string, strip any spaces, and assign it to the object variable, right, or the instance variable. Okay. And that's all setters and getters do for us, right? Which is very important. All right, so I am going to simplify this and I will oh, there is one other thing that I did want to show you as well, right? We can also we can complete these methods on one line, right? Which makes the code just a little bit cleaner, right? So instead of implementing on two lines, we can actually place the entire syntax on one line, right? And it does the exact same thing for us, right? So you may see it this way as well. All right, and what that does, it just gives us more landscape, right? More space to work with, and we use less space in our coding. All right, so let me just copy the remaining getters and setters that I have here. All right. Okay, so if you notice here, and I'll space them out just a little so that it's clear. All right, so here we have our getter and setter for name, for the name attribute. We have our getter and setter for our student ID, right? And then we have our getter and setter for the major. All right, so the same exact concept as I explained for name applies to the ID and the major as well. All right, so let's go ahead and let's create a method called display the student level, right? The student level is either they're a freshman or they are a sophomore. All right, so I'll go ahead and let's create that. Call it display student level. And I simply want to return simple string student, since we're in the student class, student in the student class. All right, so this is, so I'm setting it this way so that we can identify which particular object we're using. All right, because remember, our freshman and our sophomore objects are going to override this method. All right, and this method here is what we can call a polymorphic hook. Right, it is an overridable method, and that is intentionally placed inside of this superclass so that subclasses can hook, right, their own behavior, or so that subclasses can implement their own behavior. And what this does, it enables polymorphism, right, that allows the calling code to work with the base type, right, and the actual code in the subclass is what actually runs. Right, and you'll see exactly what I am referring to. So this particular method here is intentionally placed inside of the student class, right, to allow the subclasses to inherit and to provide their own implementation. So the student class is going to say student in the student class. The freshman class is going to say freshman in the freshman class. Sophomore class, sophomore student in the sophomore class. All right, and then finally, we want to create our string method. Right. Again, this method is kind of a common method that all developers use when you're creating classes, and it will show the state of the current object, right, that you're working with. All right, so here we're simply getting the student name by using self._name. We're getting the ID by using the underscore of SID, the major, right? And then we're also displaying, we're invoking, correction, we don't have to, but we're invoking the actual level, right, for the student itself, right? Just to show you the differences there, even though we don't necessarily have to do that, right? But we are. So it's going to invoke that method and display student in the student class for us. Okay, so you asked the question, why didn't we use getters and setters here, right? Well, we actually could have. But remember, the name, SID, and major are already in this class here, right? So it's not really necessary to use the getters and setters. This class already has access to these private attributes. So we don't actually necessarily need to go get them from a different class. Okay. All right, so next we'll create a freshman class that inherits from the student class. All right, so we can either duplicate all of this code here and retype the name, SID, and the major, all right, or we can simply inherit from the student, all right, which is what we're going to do. Okay, so let's go ahead and let's create the freshman class. And in order to inherit in Python, all right, we add open and close parentheses after the class name, right? And inside of the parentheses, we add the class that we're inheriting from. So in this instance, we're inheriting from the student class. Simple enough. Okay. So what do we do with this inheritance? All right, so in the freshman constructor, or initial, I call it constructor all of the time because that's what we call it in Java. All right, so, but they're the same thing. The concept is the exact same. They create the object for us. So I'll create the init method, right? And those are double underscores, right? And I will add my parameters. And so I'll add the name parameter, okay, that I am inheriting from the parent class. I'll add the SID parameter. I'll add my major. Parameter. Okay. In my major, I'll add it as undeclared. Okay. And then also for the freshman, I'm adding a fourth parameter, right? And this is a customized, this is a parameter or attribute that specifically that belongs to the freshman class only, right? So we'll call this first year seminar. Okay, and we'll set it stream, the spaces as well. All right, so here I am, in order to set my name, my student ID, and my major, right, I need to invoke this initializer in my superclass. And the way that I do that is by using the super method dot, and specify int and the attributes that I want set. Okay. So what this does, this prevents me from copying this or duplicating this code, right, on lines 3 through 6, 3 through 5, and adding it here, right? Which makes sense. I simply invoke this constructor, my superclasses constructor, right, and let it set the object, right? Let it set the freshman object since the freshman is a student. Okay. And then finally, in this freshman object, we'll need to set its first year seminar, right? So let's create the code to set it. So we'll do self underscore first underscore year. Seminar. First year seminar. Okay. All right, so not only are we initializing the freshman object with name, SID, and major by invoking our superclass, this constructor, right? But we're also initializing creating the objects and initializing the space for first year seminar as well. Okay. All right, so how many getters and setters do you think we'll need for this? One, that is correct, right? We'll only need one get and one getter and one setter, right? For our new first year seminar attribute. And why is that? Why don't we need one for name, SID, and major? Well, because we're using the getter and setters inside of our superclass that we've already established. Okay. And they're built the exact same way. So I'll do a quick copy and paste of those for time. All right. So now we have our getter and setter for our new specialized variable inside of our freshman class. So get underscore first year seminar, and it returns that first year seminar value. And if we want to change it or set it, right, we'll pass an argument into our set first year seminar method to provide it with a different value in that object. Okay. All right, so let's take a look at overriding, right? Remember I said that since we have inherited the student class, right, we're now considered a subclass of it, so we can override this display student level. We have access to it. All right, so let's do that. We're going to override it and customize it, all right, for our specific freshman class. So we can do that. We'll give it the same name. Display student, level. And if it contained additional arguments, parameters, we would also have to provide parameters inside of our parentheses, right? But this does not have parameters. As you can see here, we did not define it with additional parameters, right? And what I mean by that is like we have param1, param2, and so forth, right? It's not defined with additional parameters. But if it were, that means I would have to also add those parameters here when I override that method. Okay, but the only parameter that's in there is self, which is by default. All right, so instead of returning just student, this time I want to return the string freshman in the freshman class. All right, so therefore, when we iterate through our loop and polymorphism is taking place, all right, the compiler will recognize which particular object, right, the display student level method belongs to, and it will display, in this instance, freshmen in the freshman class. Okay. Simple enough. All right, and then finally, I said that most developers, again, create this string method. In Java, we call them toString methods, but in Python, they're called string methods, right? And they're also called dunders too, which is quite interesting. They're called dunders. I said I was not really going to talk much about this, but a dunder is basically a method that's used in Python classes that returns a string. In this instance, it returns a string representation of the object's current state. Right, and you have different ones. You all have actually used them. Init, right? Underscore, underscore, init. This is a dunder. All right, this is a dunder type special method. String, right? This is a dunder method, right? And the whole thing, the main objective is that they act on the Python code itself, right? It's a very easy way in which we're able to use these methods to act on the various types of data or implementation that we have in our class. You've used the length, right? The length method to get the length of an array list or of a list. All right, so we've used these methods before, right? Just to kind of iterate on that, that's what they're actually called. Right, a special method called a dunder. All right, so getting back to where was I? All right, here we are, to the string method for freshmen. All right, so I'll just simply copy and paste this as well for time, and I'll explain what it is we're implementing here. There we go. All right, so here's our string method. So if you notice here, we are invoking super again, right? And look at what we're invoking this time. We're invoking the string method inside of our super class. All right, so what does that mean? That means that it's going to store or it's going to call this method. And what does this method contain? It contains a display of the name, the ID, the major, and then the actual level, right? The current level for that particular object. So we're going to store a reference to all of this, all right, this return into this base variable, right? And the reason being is because we're pulling from our superclasses string, but at the same time, we're using this customized string method, right, that we've created that will also include the first year seminar, right? So look at what we're storing in the first year seminar variable, which we're calling extra. Okay. So we have the base string representation in this variable called base. And then we have the subclasses string stored inside of this variable called extra. So what are we going to do? We're basically going to concatenate them or add them together, right? And we're going to do that by using our slice method, right? Or the slice function, implementation, correction, right? Where we're going to take the base, right? And we're going to remove or drop the last character. Remember, we're starting from the beginning. The -1 takes us to the very end, right, of this string here that we're returning, right? So it's going to drop the last character, right, and append a parentheses, right? It's going to append this parentheses here. And what this does, and then we're going to concatenate it, right, or add this extra, right, that puts it inside of the actual parentheses. All right, so we'll have the name, the ID, the major, the level, and then for the freshman, right, the course for the first year seminar that's added. You'll see that very shortly. All right, so this is just another way in which we can use this slice implementation, just to kind of as a review there. All right, so let's create the sophomore class. Okay, so the sophomore class is very similar. The only difference is that we have created a specific method inside of our sophomore class, right, that will check the credits that the student has completed in order to be considered a sophomore. All right, so let's go ahead and let's create that. So we'll call it sophomore. Okay, we'll extend the student class. Down a little bit there. Okay, we'll create our initializer. Okay, and we'll add our parameters. Okay, we'll do the exact same thing. Sid. And for our major, we'll set this as undeclared. And we'll add our fourth parameter. We'll call it credit completed. This time we'll initialize this as an integer and we'll set it to 0. We'll invoke the superclasses initializer. And what do we want set when we do that? We want the name set, we want the student ID set, and we also want the major set. Again, that eliminates us having to duplicate this code, all right, and copy this or retype it here inside of the sophomore class. And then finally, in our initializer, we need to initialize the credits completed parameter, credits completed attribute. Okay, so we'll do self. Credits completed, close credits completed. Okay, so now we have initialized our entire sophomore object by using this initializer. All right, we've initialized it with the name, the student ID, the major, and the credits completed. So when we create this object, it's expecting us to provide values for each of these parameters, or each of these parameters and attributes as well. Okay. So we only need what? Just one getter and setter. We only have one new attribute for this sophomore class. All right, so I'll go ahead and I've set the setter up just a little differently. We're doing some validation on the setter, and I'll show you just in a moment. All right, so this is our get underscore credits underscore completed, right? And it will get the value that's currently set inside of the sophomore object, right? All right, so let's take a look at the setter, right? So you can implement validation on a setter, but before I do that, I want to create this customized method that is specific to the sophomore class. Right? It returns that the credits that a student has completed must be greater than 45 in order to be considered a sophomore. All right, so let's create that method first, that customized method. All right, now I'll go ahead and make this private because only this sophomore class will use this method. So I'll call it eligible for upper division. So how do I check to see if the student is eligible for upper division? I need to check the number of credits. So we're going to pass in a credit value, the number of credits that the student has. All right, and it's fairly straightforward. So I'll just create a constant called threshold, and I'll set it to 45. And I'll do a quick check, return if the credits that were passed in are greater than or equal to threshold. Simply that. So this will simply check to see if the student has 45 or more credits in order to be considered upper division, an upper division student level. Okay. So with that said, all right, in our setter method, if you notice, I have not created the setter method yet for our attribute credits completed, right? Here. So for the setter method, we're going to validate this. So here's how we're going to do that. All right, so you can do validation on a argument before you set the attribute's value in the object. Okay, and that's what we're implementing here. So I'll call it set credits completed. So what do I need to pass in here? I need to pass in some type of student credit. All right, credits in order to even set it. All right, in order to set the student credits, I need to pass some value in there to set it too. But I want to do validation, right? I want to check to see if the student is eligible. So I can implement something like this. If not, meaning if it's false, all right? So I can call or invoke that eligible, where are we? There we are. And this is why I created it first. So here I'm going to invoke to check to see if that student credit that we're passing in as an argument meets the criteria, it meets the threshold. Student credits. Here, let's check something. Okay, so we're going to check to see, right, if the student meets that threshold. All right, so in order to set it, I'm going to pass in the student credits. Those student credits are going to be passed into this method that we're invoking, right? Is the student eligible for upper division? I should have started that with is, all right? So it's going to check to see, so it will invoke this method. It will pass in the student credits, all right? And it will check to see if the credits are greater than or equal than the threshold, right? And it will return either true or false, right? Because these are comparing, right? These are comparable, are comparison operators. We're comparing to see if the credits are greater or equal than the threshold. So these operators return true or false. Okay, so once it returns, it will return true or false here, and it can answer the question if that those credits, right, are eligible. All right, so here I'm asking if not, meaning if it's false, if it returns false, all right, meaning that the credits are less than 45, then what do we do? Well, I'll just, I'll copy this part out, but I'll just explain it. All right, so what I've done here is simply, all right, provide a simple header under credits completed, thresholds of 45 error report. Let me change that. I just read that again. Credits completed under, there we are. Credits completed under threshold of 45. And this is the error report, right? So let's say that an admin person is entering students to determine if students are eligible to transition into their sophomore year, right? This report would generate and show him or her that either the student is, well, this report will show that the student is not eligible, right? Because it will return false if the student's not eligible. It will display the report. And I've gone a step further. All right, and notice this time I'm using get name, all right? I'm using the get name method, all right, getter to get the name of the student that's inside of this sophomore object. And this get name, right, is inherited from our student class. This is the one that we're using here. This is the getter that we're using. All right, and how do we know that? Because we do not have a get name getter inside of our sophomore class. All right, there's no get name method here. All right, so we're using the get name method that we inherited from our parent class. All right, so here we're saying display the student name by using the get name method that's currently in that object. All right, that student has completed. All right, and then it will display the student credits that were passed into this setters method. All right, so display the student credits. So Susie has completed 24 credits. All right, so that makes her ineligible to be a sophomore or to hold status as a sophomore. All right, and we'll add or an else, right? Once the credits have been verified, all right, then we can set that attribute, right? Credits completed. All right, so we'll go ahead and do self. And credits completed. We're going to use our student credit that we passed in to set the instance variable. Okay. So this is another way in which you're able to validate the credit, right, before actually setting that value, right, within our object. This is one way in which we can validate that. Okay. All right, so, and then we also have our display. We want to override, so I'll just keep those together. Move this up a couple here. All right, so then we can also override, again, the display student level method, all right, that we inherited from our parent class or our superclass student. So we can override this method, all right, and we'll say student in the freshman class or sophomore in the sophomore class. All right, so here, okay, we'll create a method that will override display student level. Here we'll return, I'll call it student in the sophomore class. And I'm going to change that up a little too. Instead of freshman in the freshman class, we'll do student in freshman class. Sounds a little better. All right, so student in the student class, student in the freshman class, and student in the sophomore class. So here again, we are overriding the display student level method that we inherited from our superclass student. Okay. And then finally, we'll create our string method to display the state of our object, our sophomore object. Okay. And the concept is the exact same using slice. We'll start at the end. We'll remove the last character of the base, right? We're invoking the base soup string method, storing that here. We're creating another string, F string for the credits completed, and we're storing that here in extra. We're concatenate them together, right? And it will add the parentheses and enclose, right, this information inside of the parentheses for the sophomore student. Okay. All right. Okay, so moving forward, our very last class that we will create, right? So we have all three of our classes, the student class, the freshman class, that in our student class, which is our super class, our freshman class and sophomore class, which are subclasses that inherit or extend from our student main class, all right? And we can override, all right, the methods that we inherit, all right? We can use the attributes that are defined in our superclass by invoking the super method, all right? We can also invoke our super method to use its toString or its string method, all right, to concatenate to our string, all right, that we have specific to our specific or customized attributes. All right, so next we'll create a main class, and we'll just simply call it class main. And this class, for the most part, will be our driver, right? It will not inherit from any other class, all right? And we'll create a function, and we'll call this function, we'll just call it execute. You can call it anything you want, execute or run. All right, I'll just call it execute. So what I am going to do is to create a student list, right, that allows me to store the list of different students. All right, I want to store a student. For my student, I want to store a student object. I want to store a freshman object. I want to be able to store a sophomore object. All right, so I will create this list that will store those different types of objects. All right, so the first thing I'll do is to create one student by using its setters, the setter methods. All right, so we can do that. So we'll just call this S for student. And what I meant with the initializers, if I did not define the parameters with values like this in my initializer, right, I would have had to have typed this information in order to build my object. All right, it would have required that I type in the name, the student ID, and the major, right, for the student, right? And I don't want to do that. You can do that. I want to use the setter methods in order to set the student name, the student ID. All right, so let's do that. So I'll use my object that I've created, dot, all right, and if you notice, I have access to set name. So I'll select set name. And in order to set the name, I need to provide a name for it. So I'll just use Jane Doe. All right, so this here, all right, this Jane Doe is the argument that I'm passing into here. Okay, so Jane Doe will be passed in to the stu name, stu underscore name. All right, this is where I'm passing that argument into this setter method. Okay. All right, so next we want to set, so I'll do set dot, and what else is next? The SID. All right, there's set SID, and if you notice here, we can see the signature for that method, right? It requires an argument be passed into it, and that's the student ID. All right, so I'll pass in a student ID, and I'll just call it S1001, something like that. Okay. I'll use my student object S again to set, you got it, set the major this time. All right, we'll set the major as computer science. All right, so if I didn't type anything in here, right, what would it display? It would display undeclared, right? The way that we set it here in the initializer. All right, but I'll pass something in there. We'll pass in the computer science. All right. And so I'll just simply undo that. So I'm setting my student object name, ID, and major. All right, and with a list, you can simply append it to the list. As you create the list, we can add to the list. All right, so let's do that. So I'll just use students, the name of my list, dot, append. All right, and what do I want to append? I want to add student. All right, the one student object that I have just created using my setter methods. Okay. All right, next, I want to create a freshman. Well, I'll just call this object F for freshman. All right, and I'll use my freshman initializer. All right, F dot, and what am I going to set? I want to set a name for my freshman. So if you notice here, which is really nice to see, to the very far right here, you could see exactly where these methods derive. So if I choose this set name here, we can see that it is defined inside of my student class. All right, that clearly shows us that we are inheriting and using this set name method, right? That our inheritance is working the way that it should. All right, so we'll go ahead and set it, and we'll call her Tracy Smith. So it also tells us that the student class is the class that's setting it, right? It's not the freshman class. Right, so we also want to set what? The student ID, all right? So we'll go look for the student SID. All right, again, it's coming from the student class. And we'll set this her up as S1002. Right, let's give us just a little bit more space here. All right. And we also need to set the major, right? Deriving from our student class. We'll set the major to, I guess, biology. Okay. However, the freshman class also has another attribute, set first year seminar. All right, so we can type in set and look clearly where that method, that setter method, is deriving from. It's deriving from our freshman class where we set it. All right, and it requires that we pass in the name of this first year seminar. Okay, so we'll choose set first year seminar, and we'll set it to, I guess, FYS, first year, 10103, something like that. That's the name, that's the title description of the class, of the seminar. Okay. So the key here is we have the student class setting name, ID, and major, all right, which is what we want through inheritance, all right? And the freshman class itself is setting its own individualized attribute first year seminar. So what do? We want to append it to our list, to our students list, students dot append, and now we have F. All right, so we're simply stacking on, adding on to our list. All right, so we're adding first the student, S, and now we're adding or appending the freshman. All right, so moving forward, let's take a look at our sophomore. We'll do the exact same thing for the sophomore object. All right, so we'll just call this SO for sophomore. Again, we're using its initializer. Let's spell it right. Let's go back and take a quick look at mine. Let's spell the sophomore class. Yep, that is correct. Has to be the spelling. Give me just a moment. Oh, I wish I could talk to you all because I would ask you, what is the problem here? Well, the problem is with Python indentation, right? Look at where I started the definition for this sophomore class. And this is really good because it's not recognizing it as a class, right? It's recognizing it as a class inside of my freshman class, which is not good. Right. So in order to eliminate, in order for the compiler to recognize this sophomore as an individual class, right, I need to move my indentation to the beginning of the margin there. All right. And again, this is what Python is really big on, indentation, which shows its scope, if you will. Okay. All right, so now the error has gone away, all right, because it's recognizing it now as a class within its own scope. All right, so here, so we want to set the name of the sophomore student. We'll call her Mary Jones. Okay, and we also want to set the SID, student ID. We'll set that to S1003. Okay, and we'll set the major. And we'll set it as mathematics. Okay. And then remember, sophomore has its own customized, its own attribute, right? Credits completed. All right, so we'll just do set. That's our credits completed. And here we'll pass. So we'll set Mary at 48, right? So that means that she will qualify to be a sophomore. Remember, the threshold was 45. All right, and then finally, we'll use our student list to append our new fresh sophomore student. Okay. All right, so this is how you're able to create. I mean, there are multiple ways in which we could do this, right? But this is the very simplistic way, I guess, if you will. And I think sometimes it's good to see how things are done at the very bare bones, if you will. All right, how to actually set them yourself, right? How to use the setter methods, how to use the getter methods, what their purpose is for. And that's why I actually like your assignment for this week, because your assignment specifies to do just this. Okay. All right, so we've set each object, right, with values, set each object's attribute with values by using the setter methods, right? So now let's use the getter methods, right? And let's see exactly if we're able to see what these values are in each object, right? And we're going to do it a couple of different ways. And I'm going to copy and paste just a couple of items here. All right, just for time. All right, so basically what I'm implementing here, I am just doing some simple formatting. All right, so what this will do, it will give me 100 equal signs all the way across. It will say using getters for each object to display their state. And then it will provide, again, 100 equal signs across, right? Just as a separator to see the different outputs. All right. So for time, well, the first one I'll actually type the first one out, right? Okay, so in order to do this, I'll use my F string. So F, okay, student name. Okay. Here I'll use S dot. If you notice, we have get name. Okay, so I'm using the get name, right, in order to get the name that we've set inside of our student object. Okay. All right, comma, ID, S dot, get SID. Okay, it's being pulled from the actual SID itself, from the actual student itself, correction. Comma, major. get major. And if you notice, it's deriving from our student class. Okay, so this will display, right, our student, right, object and all of the values that we've just set inside of our student object. Okay, and I'll type the next one also because I want you to actually see where it's deriving from, how it derives a little differently. It will, and you'll see. So let's do a print. We'll do F in. This time, this will be for freshmen. We want the freshman name. And this time I will use my F object, right? And I want to get the name, right? So if I type in get, G for get, look at where it's pulling it from. It's still pulling it from our student. It will pull the major from the student. It will pull the SID from the student class or super class. But look at where it's pulling the first year seminar value. All right, that's pulling it from our freshman class. All right. Okay, so let's go ahead and let's select get name, ID, okay, F, get, SID, and major. F, get major. Okay. We're not done. Comma. Move this down to the next line. There we go. So I'll do another F string first. Just go here. Seminar. Here we'll do F. Okay. G. Okay, so here I'm pulling my getter method from my freshman. Why? Because the first year seminar is specific to the freshman class, okay, or to the freshman class, no pun intended. All right. Okay. All right, and sophomore, for the most part, is done the exact same way. All right, so I'll just simply copy and paste it. I could type it out as well. All right, so for sophomore, the name, all right, we're using SO, the get name, which as we saw in freshman, it's being pulled. We're using the student's getter method for get name. All right, same holds true for get student ID, get the major, all right? And then we're also getting the students' credits completed, all right? But we're pulling this from the sophomore class since credits completed is specific to the sophomore class. Okay. All right, so let's run this. Okay. Yeah. So let's run this. And the way that we run this, right, is in this instance, there are many ways in which we could run it, but we'll run it this way. We'll use our if name equals name. And this time we're going to invoke the main class by using main uppercase M, main dot, right, and execute. If this works for me. All right. Initially had it set to run. Same holds true. I did the main the same way. Interesting. I don't know why that is the case. Why did I keep doing that? All right. Execute. There we are. All right. So this is the way that we're able to run, right, this module, if you will. Right. I'm going to invoke the main class dot the name of the function, which I called execute. You can name it anything. All right. So we'll execute this function here. All right. Build out each, create our list, build out each object, all right, by using the setters, and then display each object state by using the getter methods. All right, so when I run this, oh, wrong one. Stop that. Let's get the current file. There we are. It's trying to run the other file. So when I run this, this is what we have. Using getters for each object to display student, there's the student name, student ID, major, and computer science. Okay, for freshmen, there's Tracy Smith, her ID 1002, her major biology, first year seminar, FYS 1013. And then our sophomore, Mary Jones, her ID 1003, major mathematics, and the credits completed 48. Okay, so far, so good, right? All right, so that's just by using the getters. All right, let's take a look at how we're able to polymorph, right? How we can display these objects through polymorphism, right? How the compiler can determine what particular object is being used through polymorphism. All right, and one of the ways in which we could do this, we can just use the string method. All right, simple enough. And I'll show you exactly what I mean by that. So, all right, so I'll just go ahead and create a simple header again. I'll just copy, paste this. Just unlock me on that end. All right, keep doing that. All right, so this is the student roster with, is that the right one? No, it's not. Give me just a moment. Scroll further down here. Yes, it is. Correction. So this is the student roster with object validation with the isinstance method. So we're going to take a look at how we're able to display each object by using polymorphism and using the string method, right? So that's the first thing we're going to do. So the way that we can do this is by using it inside of a simple for loop, right? So if I use stu, all right, so for student inside of our students list, the list that we've already created, all right, we can just simply tell it to print each student. So the key here is that whenever we use just the object only, so what is this doing? All right, remember we have appended, right? We have appended students, right? We've appended the student, we've appended the freshman student, and we have appended the sophomore student to our students list. All right, we've appended all of those to the student list. So we have those objects stored in this list here. So we can iterate through or loop through this list one by one. And that's what we're doing here. So for each student object in this list, be it student, be it a freshman object, be it a student object, be it a freshman object, or be it a sophomore object, display that object's current state. All right, so whenever we use just the object name itself or by itself, this particular object will invoke the correct toString method for whichever object is being iterated on at the time. Right, so as I go through the iteration or through the loop, If the very first object in that list is student, it will invoke this string method and display this information, right, about the student. If the next object in the iteration is a freshman object in that list, it will invoke this string method and display the freshman information, right? Or we'll use this string method from the freshman class. If the next object in the list is a sophomore as it iterates through, it will use the sophomore's string method, right? And this is a form of polymorphism. It's a very simplistic form, right? But it's a form of polymorphism. So remember, whenever you use just the object, right, if you have that string method defined in your class, it will invoke that string method and display the output of the object or the content of that object. That's why it's so important to add this string method to every class, right? Remember, I said this is a special method called a dunder, right, that operates on various types of functionalities within the Python program. And this is one of them, right? So we use the print method. We pass in the object. It will automatically invoke that string method for us. So when I run this, it will iterate through that list again, right? And if you notice here, now we have a second list of outputs, right, of the student roster. Here we used our getters and setters, the first output. That's why I added the title, using getters for each output to display. All right, and here we're using the string. All right, we're using the string method to display that. Okay. And maybe I should add that as well. So student roster, using string, right, to display. All right, so that's a form of polymorphism. It's able to determine which particular objects to string or string method to display. All right, so first object in that list was student, it displayed the student. Second object in that list was the freshman, so it displayed the freshman, Tracy. The third object in that list was Mary, so it displayed Mary, the sophomore, and her information. Okay, so that's one form of polymorphic behavior. All right, so another type is we can actually use the isinstance, right? That is polymorphism, right? But we can use the isinstance method, right, to determine if a particular object is the type of is a student type, right? That's what we're checking for. So we're going to use the isinstance to check if an object is of student type. Okay. And then if it is, if it's true, right, meaning if it's a freshman or a sophomore, right, then it will invoke the correct display student level method to display its information. Right, so remember each class, here's our freshman class, it overrode the display student level, and it's going to display student in the freshman class. Well, our sophomore class also overrode, right, that same method, but for the sophomore class, it stayed student in the sophomore class, right? And our generic superclass, right, defined it, and it just simply states student in the student class. All right, so when we use the isinstance, we're able to check first, right, before we execute on that object, which is what we do all the time in programming. Right, so if I build something like if isinstance, right, so I'll pass in, right, the actual, did I put, yeah. So what I did, I actually put it inside of the for loop so that it's easier, more simplistic instead of rebuilding everything out. So while we're in this for loop, right? I'm going to comment this out first, this out there, so that it doesn't print our students using that string method, right? So I'm just going to focus on this is instance for now. All right, so I'm checking to see as I iterate through this list, right, if each object in that list is a student type, right? And I can use this is instance method to do that. All right, so I'll say, is the student in, is that student object, is it a student type? All right, and if it is a student type, then I'll just simply say, do something like this. Scroll down a little bit more there. Okay, and I'll do using is instance. Check if object is a student type. Okay, so that's my header there. More importantly, I wanted to print out the correct display student level method, right? Based on the object that comes through that loop. So I'll type in stu for student. Okay, and if you notice, look at where I'm pulling it from. I'm pulling that from the base, right? From the student, the superclass student class, right? Pulling it from the base there. Okay, so what this will do is it will iterate through, as it iterates through our students list, it will extract each object out of that list for each student object in this student's list, check to see if it is an instance of the student. If it is an instance of the student, display this heading, and then display our polymorph, if you will, determine which display student level method to use based on that object type. Is it a student? Is it a freshman? Is it a sophomore? All right. Or else, if anything else comes through there that is not a student type, we could tell it, we can display something like this is not a student. Okay. So that's what we're going to do. All right. So let's run this line of code. So here we have student roster using the string. That's what we initially did. But now we're validating the object with the isInstance method. All right. So it's using the isInstance to check if the object is of student type. All right. And look at what it did. Student in the student class. All right. Well, that's clearly a derivative from our student class. All right. And our student class is here. All right. And that's what its display student level method displays. It continued through our list, iterating through, and it found the next object was student in the freshman class. All right. This is polymorphism. All right. The compiler is determining what the object type is or what the subclass is, all right, in reference to our student class. All right, so it's checking if it's an instance, all right, then display the correct method for that object type. So it displayed the freshman class, student in freshman class. It continued its iteration through our list, all right, and it found the sophomore object, right? Well, student in the sophomore class. So it's using the display student level method in our sophomore class. All right. So remember, freshman overrode it. It's overwritten the display student level and provided its specialized, customized message. Sophomore has also implemented the same thing and provided its customized message. And this is what we have. So what if we pass something in that is not of a student type? Well, that means that it should catch it, all right? If we pass in an object besides student, all right, to check to see against the student type, we should get this message. This is not a student. All right, well, let's do that. All right, so let's create I guess we can create a number, something like that. Just do number equals a number, an integer object. And we know that an integer object, right, is not a student type. So let's pass that in there. Okay. So now we're checking, right, if instance, if this number, we're checking to see if number is a student type. Well, we know that it's not, right? But we want to ensure, right, just for this demonstration purposes, that this is instance works the way that it says it should work, right? So it should catch it. It will not display, it will not even go into this block of code here because number is not a student type, right? It will branch off into our else branch. Okay, so when I run the code, okay, this is not a student for each iteration. This is not a student. This is not a student. Remember, we're inside of this for loop and we're iterating through a list of objects, a list of student objects. There are 3 that we've created. All right, so it's going to iterate 3 times. And as it iterates, it's going to check because we're passing in number here instead of student or stu. Okay. So our is instance works, right? It's working to check to see if an object is of student type. Okay, so we'll set that back to what it should be set to, and we'll just comment this out. Test. Okay. All right. Well, I think that completes the demonstration, ladies and gentlemen. Thank you very much for listening. If you have any questions, please feel free to send me an email. Some of you all have sent me emails, or you can also type a message on the discussion, my virtual discussion board. I'll answer questions there as well. Okay. All right, everyone, have a wonderful evening. Thank you for listening. Bye-bye.